evening and great food and company. We've got an exciting half morning this morning and look forward to more discussions. If the slides would be on the screen, that would help. There we go. Just as a reminder, we have the Marketplace Risk and TSPA survey around trust and safety ROI. If you are interested, take a picture of the QR code or let me know or search. You'll find it and feel free to fill in. Also, as a reminder, we've got 3 additional workshops this afternoon. One is in conjunction with ID KYC in room 3.2. Then we have the workshop on image-based sexual violence in room 2.1 and understanding safety by design by Google in room 3.4. So also another packed afternoon with discussions, which will be really great. But I want to just pass it on to this morning's panelists from SiteEngine and Photo Room. So up to you, whoever wants to take the slides and the microphone. And of course you can sit.
Yeah. Thank you. Good morning. Thank you for having us. So we wanted to take this morning the opportunity to discuss AI-generated images and how that has an impact on trust and safety operations, both on the side of generators, image generators, like Photo Room, we have a pleasure having us joining us today, and for other services, hosting providers, platforms that are facing increasing amounts of AI-generated images. So maybe as a quick introduction of who we are and what we do, Elliot, do you want to go ahead?
Sure. Nice to meet you. So I'm Elliot. I'm co-founder and CTO of Photo Room. Photo Room is an app that allows anyone to create great visual content for their product and their company. We also offer an API for e-commerce and marketing. What we mostly do is removing backgrounds and generating backgrounds, but we're in the business of improving image quality. And today, Photo Room is an app with more than 25 million monthly users.
And on our side, SiteEngine, so we are a automated content moderation service. We provide customers with APIs to analyze and moderate images and videos based on a bit more than 60 different content categories. And so we're very happy to be working with Photo Room.
So to start giving you a bit of context on why image moderation is a topic for us, recently we started adding the ability to generate images in Photo Room. So just like models like Midjourney or Stable Diffusion, you start with a prompt, here a man in a suit, and then you run it through an image generation model, and you end up with an image. So the process is it's quite simple. Inputs are varied and the outputs as well. But you can see that here it can lead to quite a lot of issues, especially on the generated images. So we're going to cover the list of topics. But what we put in place for that, there are several safeguards that you can implement. The first one is moderating the input, so limiting what users can tell the model to generate. That's the easiest one to implement because you're working on text. There's a very naive approach, which is, okay, we're going to limit the list of words, but this can be easily circumvented. Like, for instance, if you limit nudity, you could say, okay, naked, I'm going to ban that word. Well, it's easy to work around that with by saying, okay, generate someone without clothing. Thankfully, you have smarter AI models that can limit the generation of this kind of prompts. And this only protects you against some kind of cases, such as nudity and violence. There are other cases, such as, for instance, generating fake events or generating images with celebrities that are harder to mitigate. The second solution is to moderate the output. So this is a bit more costly because you have to analyze images versus analyzing text. This can also degrade the experience from the user because analyzing an image takes a bit of time, and the goal for those models is to generate the images as fast as possible. So at Photorum, we worked hard to generate the images in less than a second, and sometimes it takes more than a second to analyze the results. So if you want to analyze before sending the result back to the user, it can up to double the time to analyze the image. And currently, the implementations of this solution tend to be on the very safe side. So if you look at what happened with DALL-E and Google Gemini recently, it tends to be very, very safe in what it can generate, and this can be frustrating for the user. It makes sense for the company to like prefer to have false positives than false negatives, but it can be frustrating for the user. The last option is model conditioning. So that means training your model to make sure you do not, it's unable to generate images with the content you don't want. That's the option we took at Photorum on top of the first one and the second solution. So we train a model that has never seen any violence, nudity, or celebrities, and this way it cannot generate this kind of images. Of course, this is harder to implement. It requires a lot more work to train your own model. And yeah, so this is the overview of the solutions for putting safeguards in the context of generative AI.
Now on to other services that are basically recipients of AI-generated images. What we see is that the speed, the scale at which those are produced, and the realistic aspect of those images are putting huge strains on trust and safety operations across the board. The problems are not new. They were pre-existing, but they are exacerbated by the GenAI wave, whether it's around illegal imagery, from the worst of the worst to other kinds of bad images that are getting generated in increasing numbers, whether it's around impersonation and deepfakes, whether it's around copyright and IP infringements. We have increasing strains and volumes that need to be addressed, treated, and help that is needed. And of course, there's no single silver bullet. There's not a single technology that will solve those different problematics. But what we do see as a common thread across the different challenges here is the ability to be able to distinguish AI-generated images from real ones. I think that's a common need. And it's a need that is true for when you look, for instance, at law enforcement or investigations. We hear that there's an increasing amount of reports that include AI-generated imagery. And as such, being able to tell which ones are actually real when there's an imminent threat to life, threat to children, can help prioritize resources and investigations potentially. But also when you look at more common things like user safety, user transparency, ad safety, and so on, being able to understand which is which will be important for user trust. And going forward, we expect regulations to ask that platforms actually tag and flag AI-generated content. We see some platforms requesting that users proactively flag and say this is AI-generated, such as on YouTube. Increasingly, there will be questions around what do you do with all the abuse cases where the users don't voluntarily say that it is indeed AI-generated. And so the need to identify AI-generated images is strong, and so let's maybe see first solutions that exist with Elliot.
So there are two main solutions in order to mark images as AI-generated. Those solutions are relying on the goodwill of the image generators, so they have to be implemented at generation time. And I'm going to cover the two main existing solutions. The first one is metadata watermarking. So you generate an image, and with the attached metadata, you mark the provenance, so where the image is coming from, what AI models were used to generate it. There's a standard for this that's called C03, so it's a Coalition for Content Provenance and Authenticity. This is Adobe-led, so it's an Adobe initiative. It has been adopted by OpenAI, so today if you generate images with DALL-E 2, and DALL-E in general, you get this C2PA metadata. Google, Microsoft, and many others have been implementing it. There's one main issue, is that while easy to implement, this metadata can be easily removed. So if you upload the image to Reddit or social media, they optimize the image and they strip the metadata. So all of the metadata will disappear. Another example is that if you take a screenshot of the image, metadata vanishes, and so this like removes all form of metadata. So while this is a widely adopted standard and can prove very, very useful and has been adopted by many providers, there's a main issue is like the metadata doesn't stand, and so that's it can disappear from the images. And if someone is willing to remove it, this is trivial to remove this metadata. The second alternative is called invisible watermarking. So, for instance, Stable Diffusion, one of the leading open source image generation model, when it came out, in the source code, they had an invisible watermarking system. It's very easy to remove when generating the image, but once the metadata has been, once the watermark has been added, in theory, it's baked in the image. So it would be harder to remove it. And this is something that's resists to resizing, adding filters, and other light alterations to the image. In theory, the invisible watermark should stay there. Google offers a commercial solution to watermark images called SynthID, and this is resistant to all of the above. And you pay to watermark your image, and after that, you can check if the image contains a watermark. So as mentioned, this is a pretty good solution. The only issue is that it relies on the image generator to add this watermark, and to someone using an open source solution can very easily not add a watermark, and you end up with generated images that do not have any visible or invisible way of tell if it has been watermarked. Thankfully, there are alternatives.
Thank you. So indeed, when you look at the landscape of image generators, there are the big ones, the big names. On the left side, many of whom you know, of course. Those are either already or will be implementing watermarks. Some of them, as we said, can be removed, some of them which are much harder to be removed. But when you look at the reality of the landscape, there are also lots of other models in the open source world. If you look on the right, this is a list, just a very small snapshot of random models that you can find that were taken and built by taking Stable Diffusion, the open source model, as a basis that they fine-tune or control to produce outputs of a certain type or a certain context. You can see that about a bit more than half of the images are blurred because those are adult content models. So the share of adult content is quite high in the variants, the Stable Diffusion variants. And those models, they are not on the dark web. They are actually on very well-known commercial open websites that can easily be found, and where you can just type things and start generating images that in most cases won't have any watermarks. And while in terms of volumes, the left one, so the DALL-E, Midjourney, Photo Room, etc., will be generating most of the volume right now in images, when you look at the actual problematic or abuse cases, it's mostly coming from the open source variants on the right, without the watermarks, or with chainings of apps, which are a bit more complex. So again, we're back to, for many of those abuse cases, back to square one, which is how do you distinguish them from the real stuff? And so the question for us is also, well, how do humans perform? When you look and ask someone on the street, are you able to tell if an image is AI generated? People tend generally to be quite confident. Oh, I can see that there are 6 fingers. I look at the limbs. I look at the letters. I can see it's not realistic. So we did a little test. We started, taking those images, taking real images on one side, fake images on the other, and say, okay, where's the real images here? So there are 2 real images in the 8 here. Which ones are real? It's not easy. I don't know if I'd be able to say. Do you think the snow landscape is the real one? Yeah, it's not. So the real ones are the rainbow and the coffee. The other ones are fake. And there was no post-processing whatsoever. That's the raw image you get from the generator. We didn't do any attempt to make them more realistic by cropping, by filters, etc. So it is pretty hard, and you don't need to spend a lot of time to get that kind of result. So we did a bit more testing on that, saying, okay, we have half of the real images, half of our AI, and we submit that to people and see what their scores are. If you do a random toss coin like that, random, you get 50% accuracy. That's like the worthless choice. If you now take humans, non-trained humans, we get to 65 to 75% accuracy right now. Again, on non-adversarial images, just generated images without any post-processing. Now, if you have people who are actually trained on this, who spend time looking at images, at the details, at the textures on the large screens, they get up to 85 to 90%, which is pretty good, but it's very time-consuming. They actually spend 15, 30 seconds on each image. That's not scalable, and again, it's far from 100%, so it's very challenging. If you want to test yourself, you can, we have this AI or not a quiz you can go to on the website. You'll see images, you get to say AI, not AI, and let me know if you're a normal human or a superhuman. I'd be interested in knowing how you do. So it's challenging, and the other news is that it's actually decreasing over time, of course. With each new version of the generators, it is becoming increasingly realistic, and the scores, 65 to 75% now, are going down with time. We were at close to 100% a couple of years ago. I don't know when we'll be at random guesses for humans, but in the not so distant future, I guess. So it is increasingly hard and difficult to rely on human, especially non-trained human expertise. And so that's where we actually tested and see if there's a way to recognize AI-generated images without watermarks and without human-based judgment. And so we have been doing that, training models. And what we find and what we see is that there are actually, there's information due to the intrinsic natures of those generators that can help models learn and distinguish from what is AI generated versus what is real. It is not 100%. It is AI system. So again, it's not the silver bullet. But I believe it can be an interesting additional signal, an additional tool to help with prioritization, help with flagging, help with understanding what content we're being faced with. And this type of model and approach is interesting because it actually learns to distinguish images without relying on what's actually shown in the image. And for instance, we did tests like running these two images here, the two blue ones. One is AI generated, the other one is not AI generated. And so surprisingly, for humans, it's really completely random. For models, they can still tell that, well, the right one has a pattern that is distinctive of one of the known models. So in this case, Midjourney. And so that's the interesting thing we see is that it's, again, not based on the real, if the faces are realistic or the limbs or the hands or the letters, but rather something that is not visible to the human eye. And so in that way, it's an interesting complement to human evaluations and human expertise. And so this is why what we're opening up and giving access to as an API. And so maybe to sum up and get to a conclusion on this, I believe, and we believe that the ability to distinguish AI images is crucial across trust and safety operations. Watermarks are a great solution, but they are not the single bullet, silver bullet solution for the reasons we mentioned. And what we do see is that the AI detection of AI-generated images tend to have interesting results. The results right now, they don't drop with the updates of models. Recently, you had Midjourney go from version 5.2 to 6, DALL-E from 2 to 3, etc. and the accuracies we get tend to maintain themselves. So the fact that they're more realistic does not impact the scores. And they are agnostic to the content of the image. So the other interesting thing is that even though the models might not have seen the bad stuff, for instance, we expect them, and it's a hypothesis, expect them to still be able to tell for bad images, this is likely AI generated, this is likely not AI generated. And I insist, of course, on the likely, because it is a tool, it is an AI model, and so it's a signal, not an absolute decision or foolproof result. So thank you very much for having us, and we're happy to hear if anybody has questions or...
The same principles or concepts apply for AI-generated videos, or have you found any differences in them?
Yeah, that's a great question. So AI-generated videos will be increasingly common and an upcoming topic. Right now, we focus on images, so this is really optimized for images. So you could say, okay, let's try to take frames of the video and try to check them. If you look, this is preliminary, but if you look at tests on this, the results are not as good as on images, because it's not trained for videos, but you can try doing that. And but specifically, I think this is one of the topics we want to work on and see how we can better support detection for videos, because the amount of AI-generated videos, they are becoming very realistic. We see Sora coming up soon. And so it will be interesting in seeing how that performs and how that can be detected.